All right, Spencer, welcome to the Big Ideas in App Architecture podcast. For me personally, I was requesting the team to do this podcast for almost a year. I was like, we need to have Spencer come on this podcast because I've always been fascinated by going back and kind of talking about some of the things he did over the years. I mean, I joined the company three and a half, 4 years ago. And I'm sure you guys did some amazing things that inspired me to come join. So today's conversation is all about kind of talking to you about some of the things that got the company to where it is today and learning from you as to what excites you about where we are going next, right? So that's where we're going to go. So thank you to all the listeners for coming in. Spencer, so you tell me, like, when you started this company, when you were thinking about it, like, what happened? What was that moment, what that day that you were like, need to do something about this idea that we have?
Well, you got to go back a little bit before the founding of Cockroach Labs. It certainly did not come out of a vacuum. In fact, myself and our co-founders, we started at Google in about 2002. So, at that point in time, it was, I think they had 300-ish employees, and it was mostly in one building. And they were starting to really go beyond custom-built infrastructure and starting to use databases. And my God, they had a lot of problems with them. And eventually they ended up building their own, but not before they did something that's very common in Silicon Valley, which is shard a database, which basically means that you're going to have lots of instances of a simpler monolithic, as they call it, database, and manage many of those in aggregate. And you can scale quite well, but it's a lot of work. So Google eventually got to a point 10 years later when all three of us left the company, where they were building what's now called Spanner and getting it into production. And we saw the evolution through those 10 years of databases, and also Google's opportunity and challenges, right? They had their own data centers. They were building kind of unreliable networks and hardware and so forth. And so they were building infrastructure that worked around the lack of reliability. And kind of one of the big lessons at Google is anything that goes wrong at scale will go wrong. And, the bigger the scale, the worse the problem. So all those lessons were sort of percolating when we left. And like I said, they're right on the verge of getting this really next generation system called Spanner into production. So exit Google, myself, Peter and Ben, the three co-founders of Cockroach, and also we're at Google together for a long time. We all started a company, which is called Viewfinder, which was building private photo sharing. We didn't like Facebook. We didn't want to share our private photos with the whole world, but we did want to share them with each other. And we desperately, after looking at all of the open source databases and commercial databases that were available outside of Google in 2012, we realized, what's missing is this thing that would look like Spanner. Google's a long way from open sourcing anything or even putting it into GCP, which didn't really exist at that time in a significant fashion. And we, that's where the idea of Cockroach came from. And it was just a manifesto. And that's why I got named Cockroach. Like, I never really thought that would be a company name, but I thought it was an evocative name that did describe this thing. It has to be resilient. It has to survive. It needs to be open source. It needs to be sort of a shared nothing architecture, really optimizing constantly, even when something goes away. I saw all those ideas. Oh, you know what? I live in New York City. I see these bugs all the time. They're impossible to get rid of. And it's called CockroachDB.
Nice.
But it was really the lack of having this kind of infrastructure available and the obvious need for it, having seen it work so well at Google and also seeing when you don't have it, the difficulties that just pile up. Interestingly enough, for Viewfinder, we didn't end up writing Cockroach at that point in time because we weren't trying to build a database company, right? Which maybe we just should have then, who knows? But we did get a really interesting opportunity to learn a bit more about why you need Cockroach, because at that very moment when we were thinking about Cockroach, DynamoDB was released on AWS. And it has some really cool properties, especially at the time. And so I was like, hey, we can't write this database, but we can use DynamoDB and we can, get this Viewfinder thing off the ground. And we did. But in the end, it took us about a third of all development time wrestling with the deficiencies in DynamoDB. Doesn't have transactions, doesn't do native secondary indexes. So what do you have to do? The programmers have to build all those things alongside it, on top of it. And they get real dicey because without transactions, you're just kind of waving your hands and you're hoping things work. And it kind of goes back to that dictum that mantra at Google of like, at scale, anything that can go wrong will go wrong, absolutely guaranteed, and it'll be egg on your face. Believe me, we experienced that again and again and again with DynamoDB. So third of your time wasted on a system that was not designed for like the real use cases. Fast forward, another 10 years now, and many people use DynamoDB. It blows my mind, right? So it's interesting that um, there's a market for something that has the deficiencies that DynamoDB has, but it does have simplicity, right? So you just realize there's lots of points in the solution space, but ultimately the terrible experience we had with DynamoDB, it really put wind at our backs. Like, hey, we really have to build this. This thing needs to exist, and so that's where we ultimately got started with Cockroach. We wrote a design doc, which got a lot of airtime, and venture capitalists came circling in, and some really good ones. And we said, hey, you know what? Let's build
Let's
this
do
thing.
it. Yeah. So it's I'm curious. This is fascinating story, right? I think 2010, 11 era was pretty interesting. Like there was a lot of interesting things getting developed. So many new open source databases were coming up. I think 2013 is when the F1 distributed SQL database paper came out of Google. Was that something that you guys were reading up on? Was it pre your era of thinking about this manifesto for CockroachDB?
Well, F1 was in the wings when we were still at Google. The real genesis of F1, because Spanner started as a NoSQL database, essentially. It was transactional. It had some other interesting characteristics. In particular, it used consensus replication from the beginning. But the idea of building SQL, I mean, that's a big hill to climb. SQL is very complex. It's very powerful. There's reasons it exists. It manages complexity extremely well over decades in many use cases that are in production today. What it presents as a difficulty is that it's kind of like a Pandora's box. So Google didn't start with it, but the impetus for saying, hey, we have to build relational into this Spanner thing was because it was a project that I worked on early on at Google and helped solve. And I mentioned before, sharding databases. Google did that. And that was a project I was working on called AdWords. Of course, most people know what AdWords is. It's Google's whole advertising system. When I got on the project, they were just kind of dealing with I think 2 to 4 MySQL instances. These were the shards, right? By the time they replaced it with Spanner plus F1, it had about 1,000 shards. And by the way, Facebook systems, I've heard they have hundreds of thousands of shards. So, these things can get very, very big, and it's a lot to manage. You essentially end up building a database composed of lots of MySQL or lots of Postgres or lots of Oracle instances. And it gets very clumsy and awkward fast. So, that experience with MySQL sharding at Google, they actually made that an anti-pattern. They said you absolutely can't do this on any other use cases again. But it took them 10 years to root out that evil, those evil roots that have been spreading within Google of like this ungainly system of trying to make your own database on lots of little constituent parts where none of it works well together, right? Many companies, by the way, in the Valley, the tech companies that have been around for 10 years, that's exactly the architecture they're still using. It's hard to get off these things. But Google said, we want to get rid of this. We have this Spanner thing. We believe in it. What we just need to add is an increasingly capable relational front end on it. And we're going to make that so that it's going to be compatible with MySQL initially, so that we have a pretty easy migration path because you can imagine AdWords was in its infancy in 2003 or so when I started working on that project a little bit.
Right.
By 2012, that thing had grown lots of lots of surface area, to
I
put it
can
mildly.
imagine that. Okay, we could go into that particular story like so much in depth, like, and I'm pretty sure a massive amount of people and resources were put in to kind of get that to happen. But if you see, like, what I love the fact that you kind of recognize all these things and the VCs came flooding and you start like, okay, let's just start building something together. Uh, I think the definition of resilience and scale was so different in 2013, 14, and 15, but you kind of recognized where the world was going towards. If you look at what Google and Meta or Facebook was trying to solve, they were already like big companies who are dealing with the scale, but you anticipated a world where it's going to be a problem for everybody. So how did you catch that at that early stage, and how did you see the definition of resiliency kind of evolve, and how you thought of applying that at Cockroach?
It's a great question. The 10 years I was at Google, I really came face to face with a scale that I'd never really imagined before. And that scale was both in the breadth of the different efforts Google started to invest in over those 10 years, but also, of course, the number of users they had, but also the number of data centers they were building around the world. And interestingly enough, 3 years after we left Google is when we actually started Cockroach Labs, the company. And in those 3 years, I mean, the writing was on the wall for just how utterly dominant the global public cloud was becoming. And the similarities there were just striking, right? Certainly, like the whole open source uh, set of tools and infrastructure had been proceeding apace, and they were actually starting in many ways to rival some of what Google had built internally. So Google didn't the incredible difference between what Google had and what was available outside of Google's private ecosystem in 2008 might have been somewhat unbridgeable. By 2015, there was a lot of like competing stuff. You had the whole
Right.
Hadoop thing, and did
Yeah.
equivalents to HDFS instead of GFS, and people were starting to think about replacements for Borg, which eventually became Kubernetes, and we of course were thinking about something for Spanner, and there were many other things, and there have been since. And so you just start to kind of map these things out, right? There are already a number of companies that had scale that was very challenging, right? Especially in the tech sector. Everyone needs resilience, and all of a sudden you're realizing, well, you know what? With AWS or with increasing the GCP at the time, we can actually choose regions and availability zones and all these different places, and we're not limited the way that things were in the .com era when you get a little co-location space. Instead, like there's this incredible diversity of places within minutes or seconds we can spin up resources. Well, that actually provides the opportunity to use data infrastructure and build applications and serve customers in fundamentally better ways. But you have to be clever, right? And all of the things that came before the real cloud moment arrived didn't have that advantage, and so they never built that way. Like Google recognized that very early on, so it was a huge advantage for us having spent so long at Google and seen their challenges, their opportunities, and how they ambitiously capitalize on those opportunities.
Yeah, that's pretty cool. So it seems like from the very beginning, you anticipated, this world where people would need multi-region, multi-cloud. Were these principles that were part of the manifesto that you guys were like talking about in the early days of the company?
Not so much. I'm not sure that we really locked in on the run everywhere and run across public clouds and things. That's actually things that started to become more necessary and obvious as time went by, and as some of the initial concerns that we staked this product vision on had already gained a lot of traction in the market. You mentioned that some of these things weren't obvious. I'll tell you, when we were going around talking to early prospects and people that had evinced some interest in some channel that we were aware of, and so, hey, you want to talk about it? They'd be like, well, we don't have that kind of scale, and I don't think we're ever going to have it. You kind of like, it felt sometimes like we were talking into the void, right? People did realize they needed resilience. They're like, well, is this really that much better? People didn't quite understand it. They've been using Oracle Golden Gate, or they're just, replicating some, bin log or whatever it is out of MySQL. It was pretty primitive stuff, but, things work, right?
Yeah.
So it's like, okay, we got Cassandra that actually, had a better story for resilience and so forth. And so, like, things were changing, but honestly, we did feel like we were a little bit, the proverbial tree falling in the forest, and no one to hear it. It's like it wasn't quite connecting, but there were some early green shoots for like what we were building. Certainly, tech companies where there was some ex Googlers. That was an area where people would certainly pay attention. VCs, the sharp ones, were on it, right? They saw, hey, this thing's coming. And then we had some really big financial services companies like lean into us when our product barely worked. It was like alpha, but they were like, that's what we need. Absolutely. And so you saw those things and you're like, you know what? We're a little early, but hey, it's not a bad place to be, right? Lead the target. As long as the target's going to come into sight, it's a good place to be. So we kind of had the crystal ball of looking into the future because we were in Google. In Google's past was the future. So hey, you know what? Wonderful to work at a big company that's so successful. You get that advantage that is enviable. But then we did get some early signals from the market. If we hadn't, it would have been harder to raise money. It would have been ultimately an opportunity to pivot into something that seemed like it was on the near horizon.
Right, right. I mean, it's fascinating. I mean, it's always good to go into that mindset of how it used to. I'm pretty sure when you were building this, you were not even thinking about this. You had this implicit experience that you had received from working at Google, and all of this kind of applied, and the right moment came for you to start working on this. I don't know if I've ever shared this story with you. When I was trying to play around with these new age databases, I was playing around with a lot with like open source databases, and Cassandra was one of those databases. What I hated the most about Cassandra was I could not do joins on it. And I had to like denormalize my entire application to get it to work. I still like the scale at which it could do things, but I felt like I had to let go of everything that I've learned like over the years just to make it work. And then in 2017, I was thinking, what if there was something else? And I did read about like this small project that was like blowing up. It was CockroachDB, and then and I think it's such an honor just to be able to like talk to you and people who were working on this in that time. So it's awesome. One of the things that I wanted to go and kind of ask you is, now it's been like 10 years, and is before the call you were saying almost the 11th year of the company. If you had to do this today, like if you found the company today, and with this whole new era of the world is changing with AI first kind of thought process, what would you change in your approach? Like, would CockroachDB as a product be different if we started today?
I think many of the capabilities that have come to define CockroachDB, and of course we have plenty of imitators, both like the older incumbents and fast followers that liked what we were doing and made the market more competitive. Those things that we started on almost 11 years ago now are only they've only grown in importance. Now I'd say they're almost like received wisdom, as opposed to you kind of have to imagine the future a little bit. So those things that absolutely be required. So it's a little hard to answer the question from that perspective because they become so obvious.
Right.
That of course a product would already exist. There's no way we'd be starting this company right now without realizing that we're way, way, way behind. The only
Yeah.
companies that can do that are like AWS, who created this DSQL product, right?
Yeah.
Why can they create DSQL today? Well, they can rely on their incumbency as a hyperscaler, and so they can push it to all their customers, and that can work even though they're ages late to the market and
Right.
the product's not particularly good yet. So that is actually a significant source of reinforcement that we're on the right track, that you get those late incumbents that come in. Oracle, for example, created this thing called globally distributed database, GDD, right? And they have this is just a little funny aside, they have a page on their website. So this is Oracle, right? This is a big company with many tens of billions of dollars in revenue. And for their this new product launch they have one competitive bake-off page that shows Oracle GDD on one column and CockroachDB on the other. We're the only competitor as far as they're concerned for that product. And they, as with all of these competitive matrices, right, you kind of put some check marks in your column and you put some in the competitor, but you put some red X's too, and you show that your green check marks are just, they define a better product, right? That's the standard format. Well, Oracle did this, and they put all green check marks, and it was an incredibly long list. They went like 3 or 4 pages, and CockroachDB had an X in every single one of them. They didn't even give us one green check mark. And I'm not saying Oracle is a company that isn't one that is a significant competitor. They absolutely are, but they do seem like they run into a lot of innovators' dilemmas. They have a significant business that is built on legacy use cases in 2025, and I think they've really been pivoting into becoming an AI data center supplier, and taking their eye a little bit off the ball in terms of what it means to innovate in databases.
Right. Yeah. And I think it's interesting. I agree with you. Like, you definitely working on a database. And the more I talk to companies and customers who they kind of every time they start using CockroachDB, it was so surprising, especially when I met a bunch of old IBMers who were used to using IMS, and they were like, "Hey, do you know when did IMS get used?" I'm like, "I don't know. It's the Apollo mission in the 1960s." I'm like, "Oh yeah, like it's that old, right?" When they saw CockroachDB can be deployed in one binary and has resilience and everything, it was so fascinating to get experience and information back from these DBAs who are working on databases for 30 years. They were like, "This is such a fresh such a natural perspective of looking at where the world is going and the scale at which things need to work. So I kind of have had these experiences, and I kind of agree with you. It seems like with all these competition coming into the space, we kind of, it's like affirming the position that we have been taking for so many years. So it's pretty cool. um from there, I'm curious, are there like any hard assumptions that you had to abandon as you were trying to build the company out, either technically or strategically, that you felt like, oh yeah, we got to change this thing or that?
Certainly, like Spanner, we didn't, when the project was more on the drawing boards, we didn't quite settle on, hey, this is going to be a relational database that speaks, SQL. And that was a very early decision of like, hey, if we want this thing to truly be serious, and it is for mission critical use cases, most of those are SQL, based applications. So we have to, we I think correctly made that decision very early on. Kind of on a more uh, practical level for company building, one of the interesting learnings for me as an engineer by trade and history was just a realignment of what is actually important to the customer, and
Right.
that's very different from what an engineer thinks is important, right? For me, it was like, let me tell you about all of the amazing product capabilities that
um,
CockroachDB has, and I never wanted to do either of these two things. Like I never wanted to miss talking about some what I thought was very important capability, and I never thought that any kind of customer or workload shouldn't be using Cockroach, right? Now, I think that's probably the biggest realignment, is just realizing that if you try to talk to everyone and for every use case, you're really not talking to anyone. Like you've got to get a resonant message and really focus on who's the sweet spot for this thing. And it's way better to have a narrower definition of that at first, and have a more resonant message, have something that you know is going to work for those use cases, have other credible proof points where you can point like, hey, these folks are using it very productively. Like that's an incredible position of strength, and it's very hard to let go of that idea. Hey, Cockroach is so great. We've been working on it so hard. We think it should be used for everything. Well, first of all, that's never true. There's always a better tool, depending on the use case, and it's not always going to be your product. That's for sure. So you got to let go of that conceit and just embrace, like, smaller, more focused, narrowly focused is a much better place to start.
Absolutely. And that's amazing. When you were saying, I kind of started to realize, was Cockroach, was it the second company that you were running as a CEO? Was it, or was it the third?
I took a very brief stint as CEO of Viewfinder, but like before that, I had been CTO. I've had some entrepreneurial efforts, like in the .com days. I did one, and then did one, like I said, after Google, and then we got acqui-hired by Square, which was a great sort of 1 year stint. I got to see a little bit more about the reasons we ought to build Cockroach, and then we went off and did Cockroach. And this time, I said, you know what, I think I'm ready to be the CEO. But I tell you, the hardest thing being the CEO happened about, I want to say, 5-6 years ago. And I was told by one of our early employees who was not an engineer, and she told me, Spencer, you got to stop this programming thing. It was very bitter news for me. But I realized she was right, because once you start programming, I mean, vibe coding these days, all bets are off, right? But back then, which wasn't that long ago, uh, once you start programming, at least for me, it was very hard to stop, right? So I'd be like working, working, working. I knew a meeting was coming up. I had to go talk to an investor or something. I'd be like, oh, let it go. Okay, I got to go to this meeting. And then the meeting I'm thinking about, I'm not really dialed in, and then I just want to race back to that. You can spend as much time as you have coding, that's for sure. And you always want to perfect something else. That's always been the way I worked. And I've never not had a project I was working on since I was 12 years old. And now I haven't had one for quite some time, aside from, what's the role of the CEO? It's like a bit more constrained and sometimes less interesting, but it is the duty I have.
Right. One of the things that I feel makes the conversations and the perspective that you share it different is because as a CEO, I feel like you have a very good grounded understanding of the product as well. Like you could go in and show me the GitHub repo and maybe a Git commit from somebody else, and you can look at the code and you can understand why this makes sense and why this is. And that perspective definitely comes through and shines in our conversation. So it's always great to kind of hear that. And I think that's also your strength. So it's great for us to kind of have that, right? I've been curious about this because this year, was a year of breakthrough for us. I mean, as a CEO, I'm sure you basically had to go meet so many different partners and different customers that we work with. But one particular breakthrough was obviously our IBM partnership that we had this year, right? So, what does that signal to you and to the customers who are out there, like this IBM CockroachDB partnership, and how exciting is that for you?
Well, it's an incredible mark of the maturity of our product. We've always realized, certainly from our earliest prospects and where our revenue base comes from, that we're appropriate for mission critical and often for companies that really can't afford for their use cases to go down. They're usually mature companies. We classify them as enterprise. There's a certain size to their business. They may have regulator scrutiny. There's a seriousness to what they're doing that actually makes Cockroach an obvious choice. So again, like sometimes a narrower focus is better. It's like we actually did make a brief stint trying to go at the low end of the market too, because we thought, hey, if we do both of these, then we're going to get impetus from the bottom and these champions, and then we'll come from the top down as well. Champions work with these big companies, so it all works together. The problem again is like you try to speak to the huge base of developers out there in a very resonant fashion. It's very hard for that same message to land with like a chief architect. They're different concerns and different audiences fundamentally. So we've had an interesting process there of really finding that ICP and finding the right way to serve them with our product. I think that with IBM, what we're seeing is that at the high end of the market, IBM has so much incredible traction over many decades of essentially being like the key tech partner. Like they sell. I don't know if everyone understands how IBM's business works, but they sell the vertical solution for big companies. Like they've got a consulting arm, okay? That's sort of like the big system integrators like Accenture. But they also sell hardware, and they have very, very storied hardware. Like these mainframes are still all in production in the biggest companies in the world, and they're very sticky. They have incredible capabilities. And then they sell software, and they don't just sell a small amount of software. They got a huge, huge, huge product catalog of it. And the beauty of this partnership is now Cockroach is one of the products. They have a number of SKUs where they're selling Cockroach. Their strength is that they're there through decades now, being like the key partner for some of the world's most important brands and companies. And with a partnership with IBM, it allows us to go to market with them in a far more leveraged fashion. So,
Right.
we're not doing all of the legwork and building, going through all the contractual negotiations and establishing our credibility with all of these companies individually. Now we get to do that with IBM. So it's a wonderful partnership from our perspective. From their perspective, Cockroach is a really sort of next generation database technology, which they want to add to their catalog of products that they're able to sell to their customers. It adds value. I think one way that they described it, which I really liked, is like, okay, our customers have been asking for Postgres, but what they need is Postgres for the enterprise, like real, like advanced stuff. But it looks like Postgres, but has all these capabilities. And they also, Cockroach runs on the mainframe now, which is very cool because mainframes aren't going anywhere. And ultimately, what companies want, and this is why Linux runs on the mainframe as well now. They want to modernize. They want to do it sort of without, you hear the metaphor like, hey, we got to upgrade this car's engine, change the tires while it's going down the track at 90 miles an hour or whatever. Like, how do we do that, right? Well, that's what people are doing. You can modernize in situ, so to speak. So you have a mainframe, you're upgrading to Linux, you're moving to a modern environment, you're moving to something like Cockroach, which can run on the mainframe, next to the mainframe, stretch into clusters that go on premise into the public cloud, has no data gravity in the public cloud when it's there. It can run across the public cloud vendors, and so you can lose AWS, like which happened quite recently, and you still rely on two regions elsewhere, like GCP and Azure, or GCP and a private data center. All those things are possible, right? You want to decouple yourself from like an extraordinary vendor concentration risk with one of these hyperscalers.
Right. I mean, well said. And I mean, I like the word you use, data gravity, because not many people use it, but it's like an understood term, like in the space now, right? Another thing that we had, like something that I saw you present as well, was the performance under adversity. We've had benchmarks in the industry for a while, but we put a significant investment as well in time, in terms of focusing on what it means to have performance, not under peak, but under adverse conditions, right? What was that effort, and why was it important, according to you?
I think people lost track of and interest in database benchmarking quite some time ago, but it was all the rage. If we can turn our clocks back to the early aughts and the 2010s even,
Right.
right? You had companies vying for the top position on these leaderboards for the number of
Transactions.
the cost of transactions and the total amount of transactions for a certain
Right.
set of hardware, and TPCC was like the headlining benchmark, and people sort of just lost interest in track. I mean, part of it is there's saturation, but also part of it is people were cheating on the benchmarks by creating database engines that like recognized that TPCC was running and did like different things, kind of short circuiting things. It said they were eking out optimizations to better their competitors. So it all kind of just fell by the wayside. But one of the big things we realized is the only reason that maybe not the only reason, I'm overstating it, but like a fundamental reason that you'd choose Cockroach is this mission criticality aspect. And it's kind of like people, I think, it's not, you don't always draw the line between these two things, right? It's like, well, what does mission critical mean in the context of like real production usage? It can't just be, hey, this thing it works pretty well if things are at peak load, but if you're going to repave your cluster and or upgrade your database or upgrade the Linux version it's running on or something like that, I should do that in off peak hours. Like, is that really mission critical resilience? Or is there a possibility where Cockroach gets so good, or whatever the database is, that you could say, hey, we can actually do an upgrade during normal business hours, even as we're getting peak load on this, because the database is so rock solid that you can take nodes out, or you can even do an upgrade, even like when network disks are getting flaky and EBS and or
Right.
whatever the problem is. Like you have this like layers of defense against the worst happening. And it all comes down to trust. And if that trust is high, then you can take a very different operational stance. But how do you know? Where do you get that trust from? And that's kind of where we're like, well, benchmarks are a pretty good way to do this, because a TPCC, it's a really well considered benchmark in the sense that it's like measuring, it's modeling a real use case. It's not the only use case. It's just one point in the the infinite, right, solution space of how you might build applications. But it's it's kind of like an e-commerce app that it's modeling, and does some logistics and things like that. And it has lots of nice properties in terms of how they're modeling it out and making sure that it's an even playing field, and like everyone has to observe certain requirements for how the use case runs. So that's like a great baseline. And ultimately, what we've been using TPCC for in the past is like, hey, we've got a certain amount of hardware. Like, how much TPC? They call it. I think it's TPMs or something like that, and then you do like the cost of one of these transactions and so forth. So what we actually realize is that, okay, with this is the baseline load, we could take a much more interesting scenario where instead of just running a benchmark with laboratory conditions where nothing could ever go wrong, and if it does go wrong, then you rerun it, right? Instead, we're going to say, okay, we're going to do laboratory conditions for, say, the first hour of it. And then we're going to say, okay, what are the different scenarios that are actually common for our customers
Right.
that happen? And then let's model them out and make them go from, not so great to bad to worst, right? And so like that actual progression is starts off with what we call sort of internal stress.
Right.
So we do a bunch of different things. Like we'll do a rolling restart of all the nodes to upgrade the database while the benchmark's running. Right? It's got an hour where it's running with clean conditions, and then all of a sudden you're like upgrading the database while it's running for like another couple hours. Then we do like a full backup of the system while it's running in the same like the phase of the benchmark, and then we do. I think we generated a secondary index on the largest table. So these are things, honestly, where some databases will lock your tables. You have to do this, absolutely need downtime to upgrade your database and so forth. So like you see the results with the performance under adversity benchmark for Cockroach, and it's just smooth sailing. It's incredible. And we do have customers that do their database upgrades during business hours because they have more people that are online, and they're not going to wake people up at 3 in the morning on a weekend. And then it goes into disk flakiness. And so every single disk in the system is experiencing network stalls of like 10 seconds, and they're repeated. So like that absolutely kills most databases. In fact, Cockroach didn't do too well on it until we really started to address that problem, because we started seeing it in the major cloud vendors. And then it goes through a period where nodes are getting not restarted in like an orderly fashion, but just kill dash nine, right? They're being terminated abruptly with no warning. Then we go through whole facilities being lost. We go through network partitions, symmetric ones, asymmetric ones, where it gets very confusing for these systems. And then we even go through full region failure. And in all these cases, you're just taking like, what is this application doing? What's the baseline TPCC? How is it impacted? How are the latencies, which is kind of the customer experience? How is the throughput in terms of like, are you able to handle the load that, your application has to expect and be prepared to handle? And the results for Cockroach are, well, they're extremely good. I encourage people that are listening that are interested to take a look at the performance under adversity dashboard. It is quite eye-opening and informative.
Yeah, absolutely. Yeah. And when I looked at the performance at adversity, like results, everything, and I looked at the conditions, one easy way that I would joke about it and kind of relate with this. Have you seen Wipeout, the show? Have you seen a Wipeout of? It's basically the show where like people have to run through an obstacle course, and then stuff just gets thrown at them, and they fall, and they have to get up, and they have to go and kind of complete the whole thing. But it's like a real scenario. But it's like, so it's kind of like that. The easiest way to tell is that like you hit the database through adverse conditions and different situations that you would experience in like production experience, and then you will see how it performs, right? Like, and it's like Wipeout. It's a very funny show. If you want, you can go check out
I think
some
I've
funny
seen
videos.
it, come to think of it. It's like where people have all these paddings on
Yeah,
and,
yeah.
and
Exactly, yeah. And we are basically hitting the database as is, right? No padding, just go hit it and let's see how it performs. So obviously, Spencer, we cannot talk about anything nowadays without talking about these two words or two alphabets, A and I, or AI in today's day and age, right? Like it's been phenomenal how much of this is in today's conversations, coming up in today's conversation. So we at the company also focused on adding vector as a capability, which we have done. Now we have vector search and vector index built into the product. So for folks trying to play around with Cockroach, that capability also exists. But from your vantage point, like how is AI changing database workloads, and what do you think people are not talking about?
well, AI is an incredible opportunity and also a challenge for infrastructure. It's obviously a paradigm shift. I think of importance that rivals electrification, right, which really replaced human labor, the manual drudgery, or animal labor, increasingly with machines. Well, this is going to replace human intellectual labor with this artificial intelligence, and it's definitely happening. I mean, I think the beginning of this year, when I saw deep research for the first time from OpenAI and used it, it did such a remarkable job on the first task I put in front of it. That's where I was like, okay, this stuff is real. I mean, it is absolutely going to work. At the same time, our best engineers were saying, no, this stuff doesn't quite, it certainly doesn't program like what, like Cockroach's internal code, which is, millions of lines of code and quite complicated. So, in the last 3 months, I'd say that the coding mountain is getting climbed now.
Agreed.
So, anyone that, wants to write this stuff off because they tried it and it didn't quite work, I'd say, oof, it's gonna become very obvious soon.
Yeah.
And it's gonna have profound implications for business, for the economy, for the labor market, for the world, for governments. I mean, it's really, this is going to be transformative. Is too nice a word, right?
Yeah.
It's gonna create massive dislocation, but ultimately significant opportunities. And I think Cockroach is well positioned. Like if you could have told me 10 years ago that in 2025 would be really where AI became capable enough that the writing would be on the wall, I think I would have not believed you, right? Because there were so many different instances where that wasn't the case. AI is going to do a couple things, right? The reliance that modern business has on IT already is extraordinary. We did a state of the of resilience report. It's sort of like this independent research. We do something like this every year, and we surveyed almost 1,000 business leaders, mostly in the enterprise, and asked them about their outages and the costs and the frequency. And the results were pretty surprising and alarming. The number of incidents is horrifying. The costs are horrifying, and the readiness is low, right? And so that is it's a problem, right? But that is actually a problem in the context of how much businesses today rely on IT. With AI, that reliance is going to increase, and it's going to increase dramatically and quickly. Right. So you can imagine in the future where AI agents are more and more baked in to give humans leverage. So instead of having like a big department to handle customer service, you have people that are on the front lines that are providing the relationship, the human relationship, and having a human on the other end, especially with more critical business relationships and so forth. But the AI is going to do a lot of the work and have a lot of the answers there and a lot of the history, and it's going to do a lot of querying and put it together and synthesize. We already see these things as possible now. Um, if the AI doesn't work in that case, the humans will no longer, this is going to take a couple of years, but the humans aren't going to be the experts anymore at going and finding that information and synthesizing it. And so what you're
Right.
going to have is almost like people aren't coming to work anymore, right? If it goes down, it's like the whole office didn't show up, right?
Yep.
It's going to shut down business. Business will collapse. So
Exactly.
how important is resilience in that world? I mean, mission criticality gets to a very intense, acute requirement, right? The database has to become a dial tone. Like you
Right.
never do not hear it when you pick up the phone. Like it has to be utility grade. That's a requirement. And then the other thing that is absolutely going to happen for all data infrastructure is the scale problem is going to go from, oh, well, we don't really have that much scale. We can use a monolithic system with lots of vCPUs in it. That's a lot of companies today. That's the answer. But the scale with AI it doesn't it's going to increase dramatically, right? Probably the right way to look at it is all the scale that we have today is a consequence of humans primarily hitting buttons on mobile applications. Or you hit that button, the request goes out, it hits some application server, some business logic gets executed, it queries some stuff from the database, it does some more business logic, it writes some things to the database, and returns something to the user, right? Okay, so we've got I don't know, 5-6 billion humans that are actively using mobile devices over the course of a day, and that adds up to a lot of databases, working in the background, right, doing their jobs. Well, what's happening now is we're going to get AI agents, and they're going to start doing things on behalf of humans. And when AI agents, if you've seen AI go a little wild with MCP tools yet, you may have seen that. Oh my God, it's going crazy on my database, right? And people are getting a little alarmed about this because these things they're exhaustive, right? And they're operating at machine speeds, and they'll query whatever they think they need, and sometimes it's wise, and sometimes it's not very wise, and they never sleep, right? And there's no limit to their proliferation, right? Because the number of humans on mobile devices, we're talking 5 or 6 billion, like that, how much is that going to increase? I mean, there's new apps, people spend more time on their phone, but that's kind of like this little bit of organic growth, and it has been exponential, but it's kind of got like a plateau at some point. Even as, I mean, who knows if there's really a plateau, but there's sort of a natural limiting factor, right? Now, with agents, there's no limit to the proliferation. And okay, right now, agents are a drop in the bucket. That's something to really keep in mind here. Humans are the vast majority of activity that's hitting databases ultimately in the end. And that's going to change in the next 3 to 5 years because these agents are going to proliferate exponentially,
Right.
and there's no limit. And so it's going to go from, let's say right now, some number of millions, maybe even tens of millions of agents. I
Mm-hmm.
don't know if it's that many yet.
Yeah.
It's going to go to hundreds, then billions, then tens of billions, then hundreds of billions, then trillions. And so what's that going to do for the back end, right? It's just like, okay, if you've got a popular API, you're, let's say, a middling bank in the world, and people are hitting your thing, and fintechs are hitting your API or whatever, and you're saying that, okay, well, we have 128 vCPU Postgres instance, right, or something like that, and it's very scaled. Well, we could probably double, what we have, and these processors are going to get faster, and so well, what if your data what if agents are creating first 10 times the volume that you're currently experiencing, but in like the course of 5 to 10 years, 100 times? Right? This is just like a very different problem. And in reality, it argues that scalability is and cost of scale, cost efficiency at scale are going to become probably the most important differentiators in the database market. Like one of our theses is the most cost efficient database at scale is going to win the market. Like there's an opportunity to actually win the whole database market. You cannot just use Postgres anymore. You can't do it. You can shard Postgres, right? But that is that's a little bit of a discredited architectural pattern in the era where distributed databases have fully come of age.
Right. Yeah. I mean, it's a fascinating answer. I mean, we can go into every 30 seconds of what you said and start a different podcast based on that philosophically, as well as from an architectural point of view. I don't disagree with you. I think this is a fascinating experience for me myself. I mean, I realized the other day I had like 6 agents doing 6 different things for me. I had 2 agents in the 6 verifying the work of the other 2 guys. Right. Like, so I kind of started to realize that if I am doing that, and if a bunch of people are able to start doing that, if you scale humanity and assume every human has like 3 or 4 agents working for them on one problem, we have 10 different problems that we work on. So the scale at which this has to work for the backend or whatever the world will look like is going to be profound. And I'm not surprised that everybody is talking about putting data centers in the space now, because I think we'll run out of energy to make all of this work, which is also a very fascinating conversation. I don't know if you're tracking that.
Well, I certainly am because one of the interesting capabilities of Cockroach is this ability to contend with geographic scale. So we have customers that are running across continents, and Cockroach has interesting capabilities. You can partition data, so that, for example, if you're worried about data sovereignty, you might store European users' data only in the EU and replicate it, and then you're geofencing that data, and then you might similarly store U.S. users' data only in the United States. That's good for latency. It's good for legal jurisdictions and people's sense of security for their data. You can also, with Cockroach, do global transactions and global data. So you can have very low latency, completely consistent global access to data. So this is really useful if you're doing identity and access management and authentication. You need credentials to always be up to date. And when someone changes their password or kills a user or something like that, those things are consistent globally. Cockroach does those sorts of things. So we actually have already started significantly working on the problems of like very high latency links. And what does that mean for consistency in the system? And how do you reason about it? How do you build applications that way? When you start thinking about databases or data centers, so to speak, in space, you realize that there's already an incredible communication network up there.
Absolutely.
They have like 7,000 to 9,000 Starlink satellites. If you've ever
Absolutely.
seen
Yeah.
one of those maps of them going around
I know where your head
globe.
is going right now. So yeah.
Yeah. So it's like, hey, data centers in space are going to need databases for metadata, and
Yeah.
they're going to need some coordination and consistency, for small fractions of it. But
Right.
like, you want all that to be part of one system. So like, yeah, I mean, Cockroach obviously should be used in Earth orbit, and it ought to be used as we start putting systems in more far-flung places like the moon and Mars.
Yeah. I mean, that'll be such a cool use case for us to have one distributed database that runs across the space, across multiple continents.
Yeah,
Wouldn't that be
absolutely.
fantastic?
You have like those thousands of satellites up there, and you're ultimately going to want to define regions, and that you can create a whole hierarchy in Cockroach and decide that, hey, data ought to be replicated across boundaries that you can set up. So you might and then geopartition, and you have lots of control over how it all works. But with you're essentially talking about something. Let's just say it's like 7,000 small scale data centers. It's almost like you're putting these things in 5G substations and things like that. You're talking about vast numbers. It's there's undoubtedly things that we'd want to do differently in that kind of a setup, but a lot of what Cockroach is already designed in for more terrestrial application is, I
Exactly.
think, going to have a very important part to play.
Yeah. I mean, technically, if you think about it hypothetically, if we have a data center in the space right now, Cockroach can actually work because all it needs is an EC2 instance in the space, or any server with Linux, or like some vCPU RAM, and then connectivity, right? Uh, wouldn't So technically Cockroach is already space enabled. it's,
Oh, it's space ready.
it's
Yeah.
space
I
ready,
mean,
yeah.
I'd love to explore that use case.
Absolutely. I think it's a fascinating space to get into. But I think the profound point is what you brought up is this idea that the world will need scale that we do not yet understand, but we need to anticipate for that, which is awesome. All right, so I know we've been talking for about 50 minutes. This has been a great conversation so far. Tell me a little bit about what do you think you're excited about going into 2026. Obviously with the whole AI stuff, everything that is going on with the company, what excites you about 2026, and what do you think we should be anticipating as some of the big things that we'll be doing?
I mean, it's a great question. We have a bunch of plans, as you might imagine, for the company, where you just realize that whatever we're planning for is great. We're doing the exercise, but don't expect those plans to square with reality as it unfolds, because we're going through this epic paradigm shift, and I think the future is somewhat unknowable. We can make all kinds of prognostications, and we have, but there's, I think, this incredible opportunity for us to get very good at AI. And I think companies that do that will be on the right track, and companies that don't will be risking irrelevance. Everything in our business is tied to that. One very interesting capability, of course, is really living up to this idea of autonomous databases. This is
Mm-hmm.
a concept that Oracle brought to market not too long ago, but they had some more of proto AI when they did it. But the reality, when you think about it, when you think about what these systems are now capable of, it's kind of like there's an ability to imagine that every single cockroach cluster in production is babysat by the most incredible team of experts and SREs and support people and engineers that understand all the different nuances. And you're never not paying attention to the smallest signal, and you head off any problems before they become issues of any sort. You're making recommendations, and it's just there's an ability to have incredibly detailed oversight that makes the product and experience vastly better. Like that's an incredible area which I think will come to fruition in the year ahead. There's of course, I think, a realization. There's things that we've been discussing around the increased need for resilience as dependence grows, and also the acuteness of the scalability challenge. So that's actually a really interesting point, because the timing on that is somewhat knowable. Now, do I think it's going to happen in calendar year 26? I think that's maybe a little early, but the reality is we're all going to live through an exponential scale up. It's going to happen on a doubling rate that is very apparent to our human, perspective. I don't think that's ever happened before. And like the activity of agents, I think it may be more like 2027, where it's like, oh my God, what's happening to our APIs and our backend databases? Right, but that's coming, and living through that is going to be a little bit mind blowing. It's going to create some significant challenges
Right.
for
Yeah.
people.
Yeah. And it goes back to what you were saying too, right? I've noticed in the last 3 months, like the programming skill and the capabilities have just, there's been a hockey stick pattern in the quality of the code produced. And so much so at sometimes I kind of feel like I am an agent manager more than a programmer. Like I don't feel like that anymore. Like I'm programming. I'm more of a making sure that it's doing what I want it to do. And I'm kind of profounded, like surprised by how it produces things. So, and scale that to agents.
You're at the you're pushing the envelope, right? I mean,
Yeah.
everyone's going to have to do that. If you're not learning how to manage agents in the next couple of years, I think your job is not going to be yours for very long. That's a nice way to say that. This is a crucial skill. Like, and I try to tell everyone, like, your job, whether you manage people right now or not, or you had some hope to, of course, that is likely to happen as you move on in your career, but you've got to manage agents, because agents, this AI stuff, it just has some real advantages. And ultimately, all those things that we used to think made up like the 90% of your work, they weren't always the best, most interesting things to do. You kind of like thinking about them, and you had this huge list of things that were on your to-do list. Then you kind of prioritize, say, these are the ones I actually most need to do, and other ones I can do, because there's the thinking about how to do it. Maybe I have to do some design. and plan it out, and do some cross functional dependencies,
Right.
and get other people, enlist other people to help, and then I got to do the work, right?
Right. I
Well,
agree.
do the work thing, that's actually not what you should be doing anymore. And
Yeah.
if you're still doing that in 2 years, you're going to be at extraordinary risk. So, like, what the beauty of this AI is, like, you have to get good at telling it what to do, because AI is very scalable. It's very fast. It never stops, and those are nice qualities when you're asking someone to do work for you. And it's an opportunity, of course. And I think it will be, as I said, has have a lot of negative externalities, certainly in the short term. However, it offers, I think, people that really love what they do an opportunity to do a lot more of the things that they truly
Oh,
love.
absolutely. Yeah, yeah. I mean, I wouldn't be surprised if many of the people I know will become filmmakers and artists,
Absolutely.
because AI is just democratizing creativity, right? And there's so much more that we can get into, right? But I wanted to ask you as we close, in this fast-paced world, we've always said that the world has been fast. Like the last 20 years, we feel like it's been moving fast. Now with AI, it's been like massive. How do you center yourself like in this space with massive amount of information coming? How do you center yourself, abstract the right information? Are you using any large language model support to kind of consistently look at what you need? Do you have your own agents running? Tell me a little bit about how you do it as a CEO with all that's going on.
Well, I do constantly, put tasks to the foundation models. I mostly use ChatGPT 5.2 now, and Gemini 3. I actually find is pretty good, and sometimes Grok. So they're all kind of vying. And if I was coding, I'd certainly be using Claude, which seems to be the great system. One thing that you realize with all these, and the reason they've gotten so much better, at least in my opinion, I'm not building these foundation models or anything close to it, but you look at the core strengths of each of those vendors, right? Google has so much of the kind of productivity workflows, right, that they're helping with now, because there's so many companies that use their productivity apps and so forth, that have a lot of collaboration built in. I'm sure Microsoft gets that signal too, to an extent. You have Claude Code, and just the Claude models. There's so many developers have used those things, and then you've got Grok has this advantage of being fed the kind of global zeitgeist of these Twitter X conversations. And OpenAI has, like, everyone in the world basically trying to ask it to be their therapist, or
Exactly.
help them get their little things done or whatever. And in all those cases, what you have is you have this incredible feedback loop, and
Right.
all of those companies are
Agreed.
using it as they're pedal to the metal, right, with that feedback. So someone says, let's say you're using Claude for coding, and you put in a request, and it comes out with something like, well, no, that's not quite right. I want you to do this, or could you work on this section, or hey, could you add this feature? And so in the future, it's gonna improve the output in the first place, especially if it gets many signals of people asking the same thing. It's going to say, hey, would you like this new thing, because someone had asked for that in the past. And this kind of feedback loop has been part of
It's
everyone's
fascinating.
product journey,
Yeah.
right?
It's
Everyone.
it's
But
fascinating. Yeah.
the sheer volume. Think about OpenAI's volume. Oh my God. Right. So, like, their ability to realize, to learn from what in the past caused users to be like, no, 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 like, or like, that's why you so stupid, or whatever however people interact with their AI. Like, all of that is going back in, and it's like the volume, the scale, and the constant interactions, and the ability, the constant rebuilding of these models. There's it's like people are like, oh, well, we kind of got to the end of all of the data that's
Training.
out there.
Yeah.
It's like, no, no, no.
Yeah.
Like,
I mean, I think.
we are at the tip of the iceberg, right?
Yeah.
Because
Yeah.
it's
Yeah.
all going to be created, and it's all going to be purpose created, and like each of these models has their own domain where they're going to become more and more expert.
Right. And I think what everybody kind of forgets in that conversation is that the biggest variable in this equation is the human being involved in this feedback loop, right? The same information provided to you and to me, we look at it differently, and we'll say, I like it this way and you like it that way. Like, because we have our thoughts and human reasoning and emotion and all these things that we attach to it, and that can never be taken away, right? So I think at one point we feel like these agents are so good, but at the same time, I'm profoundly excited about the future of this in at scale, but at the same time, what humans will be capable of doing. Right. Like, so I have a very positive outlook of what agents are going to do for us, So we'll
Well,
see,
I do too. I mean, this is like fire, right?
Yeah, yeah,
Or whatever. It's going
yeah.
to people are going to burn down villages by accident or on purpose, but it's also going to provide heat and cooking and so forth, right? So it's an amazing tool. It will be misused. Like that's just the reality. Like this stuff isn't. It's only going to get adopted more because of its incredible utility. It. I think you kind of have to take the good with the bad, but it's just simply inevitable at this point, which is reflected in the incredible growth that we're all seeing. And I think there's a larger open question of like, well, how is this reflected in the markets?
Right.
And are we in a bubble? And when's the correction going to be? And when will things come raging back as they always do?
Thank you so much for your time, your thoughts, and for everything that you do. I mean, it's always exciting to hear you speak and learn from you. So everyone listening in, check out the link. We'll add all these different references to Cockroach Labs, some of the cool things that we announced this year, performance under adversity, as well as the latest capabilities around vector and AI. Thank you once again for dialing in. Appreciate it. Thank you, Spencer, once again.
Thank you.